All right, everyone. Last week we started out by graphing exponential functions, and this week we are going to learn how to graph logarithmic functions. And so here's some just general facts about exponential functions and then the inverse log functions. And so we know the exponential functions are one-to-one. Remember, that means they pass the vertical and horizontal line tests. And so it does have an inverse function. The domain of exponential functions is always all real numbers. And the range of the exponential function is y is greater than 0. So an exponential function that hasn't been transformed has a horizontal asymptote of the x-axis, and the y-intercept is 0, 1. All right, so since log is our inverse function, it is also a one-to-one. The domain of the logarithmic functions, now remember, domain and range is switches for inverse. So if we had a domain of all real numbers and a range of y is greater than 0, now we have a domain of x is greater than 0, and the range of logarithmic functions is all real numbers. If we had a horizontal asymptote before, now we have a vertical asymptote of x equals 0, which is the y-axis. And instead of having a y-intercept, we have an x-intercept at 1, 0. So you may want to pause right now. Make sure you get these notes down. I'm going to move on. If I told you just to graph, I want you to graph log 2 of x, you would have no idea where to start. And so where we start is we're going to start with the inverse function, because we do know how to graph an exponential function that is y equals 2 to the x. So 2 to the negative 3 is 1 over 8. 2 to the negative 2, 1/4. 2 to the negative 1, 1/2. 2 to the 0 is 1. 2 to the first power 2. 2 squared is 4, and 2 cubed is 8. So we're used to doing this from graphing exponential functions. Now we're going to look at the inverse function. So notice inverse is where we always switch x and y. And so this table of values is for the inverse, which is equivalent to log base 2 of x. So I'm just going to switch my values. I now have 1/8, 1/4, 1/2, 1, 2, 4, and 8, because my x and my y values switch. And then my y values become that negative 3, negative 2, negative 1, 0, 1, 2, and 3. And again, if you want to pause and make sure you get these tables filled out, I'm going to move on to looking at the graph. Okay. So let's look at this graph. So these are the tables we had from the previous slide. So if you didn't get them or you didn't pause, maybe you want to do that now. And let's just remember what graphing the exponential functions looks like. So at negative 3, I'm at 1/8, negative 2, 1/4, negative 1, 1/2. And then we have our y-intercept of 0, 1. Remember we said that on the parent function, that's what we would have. Then over 1 up 2, over 2 up 4, and over 3 up 8. So 5, 6, 7, 8. And if I draw that in, I get my exponential function, where we can see my domain. X is a set of all real numbers, and my range is y is a set of 0 to infinity. So that is my exponential function. And now if we go to graph my inverse function, I'm going to go over 1/8 and down negative 3. And then over 1/4 and down negative 2, over 1/2 and down -1. And here's my x-intercept of 1, 0. Then I'm going to come over 2, up 1, and then over 4, up 2, and then over 5, 6, 7, 8, up 3. So here is our logarithmic function. So you now have learned how we're going to graph just basic logarithmic functions. We're going to take the exponential function and flop those. And maybe you don't want to do all those values, but you should probably do at least that many values. So -1 up to 2 will give you a nice shape of a graph. Now let's look at the domain for the logarithmic function. So notice my domain is no longer all real numbers. I have a vertical asymptote at 0. And so my domain is now going to be x is a set of 0 to infinity. But my range now is all real numbers. So y is a set of all real numbers. And if you remember way back when we first started looking at inverses, we said that inverse graphs were reflection over y equals x. So if I kind of draw that through, I get my imaginary line y equals x. And you can see that the logarithmic graph is a perfect mirror or reflection over y equals x. Please go on to the next video after this, as this is just showing you the basis of graphing logs. The next video will show you how to graph transformations of logs, which is really the focus for pre-calc.